Hello everyone, here is your introduction to the polygon angle basics. We're going to discover the formulas, if you will, sort of the patterns to get the sum of both the interior angles of a polygon and the exterior angles of a polygon. We're going to start with the interior. So you're going to want to fill in your chart as we go. So just start in the first box here, basically just draw a triangle. And the question I'm going to ask is, how many sides? Of course, that's 3. How many triangles do we see? I know that seems silly for this one, but it is 1. And then the sum of the interior angles. So if I were to add up this angle, and this angle, of course we all know that adds up to 180 degrees. I know that seems like review, it is, but we're going to actually use that concept to help us find a pretty neat pattern. So look at the second box. So draw a quadrilateral, okay? How many sides do we have here? 4. Now this is going to be the interesting part. How many triangles are there? Well, I want to make sure that I have unique triangles using the vertices that are given as the vertices of the triangle. So I'm not just going to draw, both diagonals here because then I've repeated some of the triangles. I'm just going to draw one diagonal here to represent 1 and 2 triangles. Okay? If I go this way, I know you're going to say, okay, Mr. Miller, isn't that 4? But then you have a vertex here that's not one of the vertices of the quadrilateral. Okay, so I want to just unique triangles that don't overlap, and the vertices match the vertices of the shape we're starting with. So there's actually only 2 triangles here. Now you might already know the sum of the interior angles here, but we're going to sort of see in the pattern how this works. But you might already know that the angles all have to add up to 360. And the easiest way to remember that one probably is, if this was like a rectangle or something, or a square, all the angles would have been 90, that adds up to 360. Well, any quadrilateral that looks like this, or any quadrilateral, will add up to 360. Okay? How about this one? 1, 2, 3, 4, 5. Do you happen to remember what that's called? Okay, good. Pentagon. 5 sides. Now again, triangles, I want to keep them unique, and I want to keep them from, using the vertices. So the easiest way to draw them, if you were going to draw it, is just start at one vertex and draw as many diagonals as you can from that one vertex. And that'll basically give you the idea of how many triangles there are. I didn't draw that one so straight, but you get the idea. 1, 2, 3 triangles. Now you probably wouldn't know the sum of the angles, for a pentagon off the top of your head. However, you might start to see the pattern. Each triangle is 180, right? This is 180, this is 180, making 360. So this one's going to be 180 plus 180 plus 180. That's 540 degrees. All right, let's go to the next one. How many sides here? 1, 2, 3, 4, 5, 6. Anybody remember that name? Hexagon. How many triangles are here? Again, I'm going to use one vertex to kind of draw them, just so I don't accidentally overlap them. Almost looks like a seashell. 1 triangles, 2 triangles, 3, and 4. So there's 4 triangles, and each triangle is exactly 180 degrees. So that ends up being 720 degrees. And at this point, if you haven't already, you might start to see the pattern. Every time we add a side to our polygon, we seem to add another triangle, which adds us another 180 degrees. So here, let's try this one without drawing the triangles. How many sides? 7. How many triangles would you expect? This was 1, this was 2, this was 3, this was 4. That's 5. And at 180 degrees for each one, 180 plus 720, 900 degrees. You could double check it. 1, 2, 3, 4, and 5. 1, 2, now it really looks like a seashell. 4 and 5, and there's your 5 triangles at 180 a pop. That's 900 degrees total. 1, 2, 3, 4, 5, 6, 7, 8. Also known as an octagon. Number of triangles, you would expect to see 6. Sum of the interior angles would be another 180 beyond what we already did, or 6 of the triangles at 180 apiece if you want to draw them. It might look something like this. Maybe we've got 1, 2, 3, 4, 5, 6 triangles. So you're not going to need to draw them every time. This is just to give you an idea of the pattern. But if you can see it, and that's why these angles are the way they are. We've already proven the 180. We proved that a long time ago. But if you can accept that, you can accept how to get all of them no matter what. So let's summarize. The Polygon Interior Angle Theorem basically says the sum of the interior angles of a, and I'll explain this part in a second, of a convex polygon is, and let's see if we can come up with the formula. So we have the number of sides, we're going to just call that n for number of sides. We have the number of triangles, and then we have the 180 degrees for each triangle. Well, let's figure out how many triangles there are in each one. This is 1, obviously. This is 2, 3, 4, 5, 6. But how does that relate to the number of sides? If the number of sides was 3, how many triangles? 1. Number of sides was 4, how many triangles? 2. Number of sides was 5, we had 3. 6, we had 4. 7, we had 5. 8, we had 6. If we have n number of sides, how many triangles would we have? Well, that would be n minus 2 number of triangles. Oops, sorry, got cut off there. N minus 2 number of triangles, because again, this was always 2 less than the number of sides, 2 less than the number of sides, 2 less, right? You take the number of sides, subtract 2. Take the number of sides, subtract 2. That's part of the formula. That tells us how many triangles there are, but to get the amount of degrees, each triangle we know is 180, so if this represents how many triangles there are, all I have to do is multiply that by 180, and we get our total. So this is the formula for the sum of the interior angles of a convex polygon. And what I mean by convex is probably the way you would normally draw them. Okay, all of these are convex. Concave is when you have something like this. If I were to draw a polygon that went like this, okay, see how it kind of caves in on itself? If you extend the sides of one of the sides of your polygon, and if it goes inside the polygon, that's called concave. That's not what we want. So I actually am going to do that because none of this works if you use concave. Okay, so all our polygons, I think, in these examples are going to be convex. So don't let that throw you off. So this is the formula. Okay, so let's go ahead and do an example or two and see how that goes. Find the sum of the measures of the interior angles of a decagon. All you got to remember is how many sides are in a decagon. That would be 10 sides. So n is 10. So then the sum would be 10 minus 2 times 180, which is 8 times 180, which is, what do we got here? So that's going to be plus another 3. So what? 1440, 1,440 degrees. There's your total right there. Okay? How about one like this? Please find the measure of angle A. So angle A is down here. Well, it'd be nice to know what the total is supposed to be, right? If this was a triangle and I said, here's two angles, find the third one, that wouldn't really make sense in this case, but you would just subtract them from 180, right? Well, I got to figure out what to subtract them from. So 1, 2, 3, 4, 5. N is 5. So my total is going to be, n minus 2 times 180. That's my total, right? So that's my sum. So that's going to be 5 minus 2 times 180, which we actually did that one already. It's actually up here. But you could just, figure out the 540 again. That's the total. So that's the grand total of all the degrees I have to play with. I've used up 124, 122, 114, and 83. What do I have left over when that's all said and done? However you want to do it, you want to add up. I think a lot of us end up doing it like this. We just add up how much there was already. Okay, so it looks like I've used up 443. So 540 minus 443 and is 97 degrees. So that would be your angle A. All right, if you want to set it up like an actual equation and do, x plus 83 plus 114 plus 122 plus 124 equals 540, you'll still get the same thing. All right, but the idea, though, is to use the total to help you figure that out. And that's how that works. Okay? Now for this one's actually a little easier, I think. This one, I know you don't have these pictures yet, so you're going to want to sketch that in, but I'm going to actually show you this in a different way. I'm going to show you this here. Now don't worry so much about the numbers themselves. I can move these around. The key is I want to know what the total is, right? The whole point of this is to eventually figure out the total. So if you could just kind of look at those numbers, you might be able to tell what the total is going to be. And I will show you, if we add them up, plus this one, you actually get 360 degrees. Which is interesting because the inside is supposed to add up to 180, but no matter what I do, I get the total here is 360. So when I go to fill out this part, I'm looking at number of sides, 1, 2, 3, and the sum of the exterior angles. So I've got 1 here, 2 here, and 3 here. That's 360 degrees no matter what. Okay? What if I sort of split this off let's see, split this point. Okay, now my total's off because I'm missing an angle, right? Which one am I missing? Let's see. I believe I need to add in this one. And now if I put the total and make that a little smaller so you can see it, the total ends up being 360, no matter what I do. Now here's where you can really see the concave happen. Watch, so convex is here. As soon as I make it go inside, look at that, gets all messed up. Because the angle doesn't know what to do, the inside one or the outside one. So if it's convex, it'll work out just nicely to get the total of 360, which if I look at my 4 sides, 1, 2, 3, 4 exterior angles, right? 1 at each vertex, grand total, 360. All right, that's got to just be a coincidence, right? They can't just always be 360, can it? Well, I'm glad you asked. Let's take a look. Split this one off, split that point, and add in the missing angle, because again, this is only 4. I got to add in the 5th. That's the one I'm missing. Check it out. 360. Again, only convex. Concave, it gets all messed up. But convex, it works out perfectly. Where 1, 2, 3, 4, 5 exterior angles. So 5 sides, 5 exterior angles. The total is 360. Okay? The proof of that is a little more involved, a little more algebraic. In class we can show that, but for right now, hopefully you can see the pattern. 360, 360, 360. I can do that all day long, and I'll get 360 every time. The sum of the measures of the exterior angles of a convex polygon, is 360 degrees. It's not even like a formula, it's just a rule. It just is what it is. So you just have to remember they always add up to 360. All right, so looking at this example, find the sum of the measures of the exterior angles of a convex 15gon, so a 15-sided figure. There's no real formula to do. 360, done. Please find the value of x. Again, I know the total is 360. The problem is this time I actually have to figure out how much has been used so far. So I do the exact same thing I kind of did on that other one. And I say, all right, how much have I used up? I've used up 67, 96, 59, 59, and 86. I've used up 308. 360 minus 308, of course, is 52 degrees. That's how much is left over for x. And it's as simple as that. So that's why I think this one's a little easier. You just have to remember they add up to 360. Whereas this one, you have to do a little bit of work. But the main idea for this one is simply just how many triangles do you have? And it's n minus 2 number of triangles. Because I know you know the 180. You just have to remember to multiply that by how many triangles there actually are. All right, that should take care of the basics. In the second video, you'll see the advanced types of problems. And if you have any questions, just let me know.